All right, so in theory, a good scientist could figure out how much gas gets produced during a chemical reaction, which is what stoichiometry is going to tell us. So, here we go. The background of stoichiometry was if you start out with a certain moles of A, how many moles of B was required, or do you need, or something like that. Okay? How much gas gets produced if I start out with baking soda? All right? How much gas gets produced if I start out with baking soda? That's my B and my A. Are you with me so far? All right. So, do you remember what the word stoich means? It's a ratio from B to A. Okay? It's that ratio. You're going to multiply by the ratio of B to A. Okay? And there's one more quick definition. A mole of gas is measured to be exactly 22.4. Oh my gosh. 22.4 liters. Okay? Write this number down. Does anybody remember how many atoms are in a perfect chunk?
6.4.
6.02 times 10 to the 23. Good job. Okay, that's how many perfect dots are in a mole. How many perfect liters of gas are in a mole? 22.4. Okay, so we're going to expand our GMA. All right, we'll just go straight into the warm-up. All right, here we go. Stoichiometry. It's gone. Okay, here we go. One perfect chunk of gas is 22.4 liters. Okay, so imagine 22.4 liters of Coke. Okay, 22 liters of Coke standing here. It would take up like this much space, right? Okay, that's what we're going to call a perfect chunk of gas, 22.4. All right, so let's warm it up. This is from last semester. How many moles are in 12 grams?
6.
How many moles are in 12 grams of NaCl? Start with the 12. Divide by the molar mass. Very good. How much does NaCl weigh? 58.45. Okay. In that conversion, take the given 12 grams, put 58.45 grams on the bottom, and what is your answer? Do we have a perfect chunk? Do we have less than a perfect chunk? How many moles is this going to be equal to? Perfect. 0.2, 0.20, whatever. Okay. Do you agree that how many moles are in there? 12 grams. Do you agree that it's a 0.2 mole? Perfect. All right, let's try it again. How many liters are in 3.5 perfect chunks of gas? 3.5 perfect chunks of gas. How many liters is that? What do we do? 3.5 what? Thank you. Good. 3.5 times 22.4. How many liters of gas are in 3.5 moles? Are you with me? Okay. You have to use your imagination like I keep saying over and over again. 3.5 times 22.4. How many is it? It turns out to be about how many liters? 78.4 liters. Agreed? Okay. What about this one? We have 51 liters. We have 51 liters. There's this huge space of 51 liters right here. Gas. How many perfect chunks are in there? What would we do? Divide by? Divide by what number? How many liters are in every perfect chunk? 22.4. So in 51 liters, how many perfect chunks do we have? 2.28, right? Perfect chunks. How many moles are in 51 liters? 2.28 moles. Remember, a mole is a molecular weight. It is a standard perfect unit. So how many standard perfect units do we have? We have 2.28 of them. Agreed? All right. Skip this one for a second just for the sake of time. How many liters are in 2 moles? 2 perfect chunks. 2 moles. 2 perfect chunks. How many liters is that going to be? What do I do? Do you agree? How many liters are in 2 perfect chunks? It's going to be, what, 44.8, right? So with a gas, we now have to imagine how much space that gas takes up. Do you think this is a mole of gas?
Yes.
A mole of gas is 22 liters. Is this a mole of gas? No. Is it way less than a mole of gas? Yeah, way less than a mole. Okay, that's way less. That could be like 0.1 mole. All right?
Are you going to burn that?
What? No. All right, so here we go. Let's start some stoichiometry. Okay, what does the word stoichiometry mean? Stoichiometry is a ratio between 2 things. How many moles of calcium carbonate are required to produce 3.5 moles of carbon dioxide? There's your given information, carbon dioxide. They're asking what? How much what? Calcium carbonate, there's our B. Okay, so if you want to produce 3.45 moles of carbon dioxide, do you see how it's a 1-to-1 ratio? So how much did you need to start out with? How many moles of calcium carbonate did you need to start out with if you want to produce exactly 3.5 of the other one? It's a 1-to-1 ratio, so what's the answer? Perfect, yeah.
How do you know it's 1-to-1 ratio? Because it says right there.
Because there's a 1 and a 1. In our equation, it's a 1-to-1 ratio. Okay, that was a warm-up. This is stoichiometry. The word stoichiometry means look at the ratio that's given in the balanced equation. Okay, you might be getting there. Let's try it again. Okay, let's balance this real quick. This is like, so last semester. C2. That means we have to put a 2 here. H4. So we need a 2 there. And finally, how many oxygens are in the back? 2 plus 2 more. How many are in the back? 6. So what number goes here? A 3. Perfect. Okay, there's our ratios. All right, let's relate it back to our demo from a second ago. Remember stoichiometry, how much gas gets produced from baking soda? How much gas gets produced from baking soda? So this is how much water gets produced from 3 moles of ethylene. Okay, there's your given, and there's your question mark. Do you agree? Okay. So if you put in 3 moles of ethylene, Which one of these is ethylene? Do you guys know? Is this ethylene? Is this ethylene? Is this ethylene? Yeah, that one. Okay. So, if you put in 3, what is that B to A ratio? It's a 2-to-1 ratio, right? So how many moles of water gets produced? What's the answer? Yeah. Are you with me? All right. Those are the first 2 questions. Have we knocked off any dust from last year? Yeah? Did you remember Stoic at all? It's a B to A ratio. Perfect. Okay. How much water gets produced from 3 moles of this? Well, if you want 3, it's a 2-to-1 ratio, so you're going to get 6. Agreed? All right. Let's take it a step further. This is what we call a part 2, which means we got to do 2 steps. How many liters of chlorine? If you start with 7.5 moles of this. Okay? Awesome. How much chlorine will be needed if we want 7.5 of that? So there's your A, there's your B. So if you start with 7.5 moles of this one, what's the ratio here from B to A? There's your A, there's your B. Do you know what that ratio is going to be? It's a 2 to? Perfect. So, what's 7.5 doubled? 15? Moles of chlorine, right? But we don't want moles of chlorine. Now we have 15 perfect chunks. How many liters is that? You have 15 perfect chunks of chlorine. How many moles is that? Sorry, how many liters is that? What's the very last thing that we got to do? Perfect. What is 15 times 22.4? 336 liters. Yeah.
Why do we always multiply by 22?
Because a perfect chunk of gas, somebody in the world, I don't know who, but somebody decided that 22.4 would be the perfect amount of a mole of gas. So the number is always 22.4 no matter what, if they ask for liters. Okay, one more time, I'm going to work it out. Here we go. We're on hole number 4. We're almost done with our golf game. How many moles of calcium? If you're starting out with that many liters of carbon dioxide. There's your given. That's what the question wants to know. But this is a problem. 4.29 liters. Is that a mole to mole ratio yet? No. Can I get it to a mole? 4.29 liters. How many moles is that? Does 0.19 sound like a good answer? So if you convert this to moles of carbon dioxide, now we can look at our B over A. Agreed? What's the B over A? What's the ratio there? There's your B. Carbon dioxide, there's your A. So what's the ratio of those two things? It's a 1-to-1 ratio, right?
If I would have said 2 to 2, would it be the same thing?
Yes. Okay, so how many moles of calcium carbonate will be needed from that? It's a 1-to-1 ratio, so the right answer is also what? 0.19 moles of calcium carbonate. Okay. Can I do one more and we'll call it a day?
Yeah.
All right, sounds good. Ooh, this is a part 3. Yikes. All right, here we go. If 2.45 liters of benzene, there's your given. We want to know what? Liters of water. There's our unknown. Do you guys agree with me so far? Okay. If you're going to relate this to our little demo, this would be like, if you started out with that much baking soda, how many liters of gas? Ooh. All right, so here we go. The given information, 2.45 liters. Is that a problem? What do I first have to do? Convert it into moles. Okay, do you agree that 2 is a really small amount out of 22? Does it agree that that's only like 0.109 of a mole? Yeah, absolutely. Okay, this is a very small piece of a mole, and we want to know how much water gets created. Okay, here's your B. Here's your A. What's the ratio from B to A? Did you see the 6-to-2 relationship there? Perfect. Okay, which is the same thing as 3 times as much. So if it's 0.109, does it make sense that about 0.328 comes out? But that's moles of water. What's the very last step in this problem? By what? Multiply it by 22.4. Don't act like you guys are smart. You don't know what you're doing. You're like, no, really, I don't. Yes, you do. All right. In fact, you'll end up with 7.35 liters because you went through that entire stoichiometry process. All right. If you get this, awesome. If you don't, let's stick to that comprehensive quiz and you'll still make an A even without these 2 problems on the test. Okay? And if you do your review, you get an extra 5 points, so that makes up for this lecture anyway.
When is the test?
Not till Friday.